is there any research being done? Is there any hope of regrowing Purkinje cells that have been damaged, of reversing the effects as you've had the results with encephalitis forms of the paraneoplastic syndromes?
Yes, but for this type of diseases, I think that is very distant. This is certainly something that I would not. Some patients sometimes, or families of patients, ask about this, and unfortunately nowadays, you can find whatever you want. Someone in the world is going to do it. I mean, good or bad. In this case, I think it's bad, because this type of cell therapies for these particular diseases have not been proven at all.
Mm-hmm.
At all. So one has to be very careful with this. I think that there's a lot of research to be done, but I don't have any model in mind, or I never read that in models, animal models or so, to regenerate Purkinje cells. Okay. There are areas in the brain, the humans, and in mice, there are areas in the brain, but not in the cerebellum, in other areas that there is neurogenesis, okay, and so, not so much there is neurogenesis, but in the cerebellum, when the Purkinje cells are gone, they are gone.
Mm-hmm.
They are gone, and it doesn't mean that we have to take this as a fact that it's going to be forever like this, and we don't have even to invest time to do this. No, just the opposite. But this is an area of research. It should be area of research, not yet not even thinkable to use it in clinics at this point, at least for the cerebellar degeneration.
On a hopeful note, however, if we, the body is a very adaptable thing. The brain is a very smart thing, which is good. We have neuroplasticity, we have ways of working around and finding. There's been people who've lost large sections of their brains and gone on to recover basically all their faculties. Is there hope in that at least we could recover some of what's gone?
If it's, I think there is a component of plasticity in some areas of the brain more than in others. In the cerebellum, I think the plasticity is very relatively low, and it's very difficult to judge what is plasticity versus learning strategies to overcome these deficits. Right? So I think you have to grasp all the possibilities to help these patients. But I don't see too much at this point. At this point, I don't see too much plasticity to play when the Purkinje cells are gone. Purkinje cell, the cerebellum anatomically is fascinating, right? Sometimes I remember a couple of artists that I met in my life, and they came to the office, and they're pure artists, you know. They look at the brain and sections of things like that, and some of them are fascinated about one area of the brain that's called hippocampus, because the anatomy is beautiful. And then another one, and the other one that has this incredible, beautiful anatomy is the cerebellum. You know? And the cerebellum has like 3 layers of cells, right? In the cortex, right? And there is one layer that's called the most external one. It's called molecular, and then there is there are a lot of fibers there connecting to different areas, and some cells also. But it's a lot of fibers, you know, parallel fibers connecting to each other. Then there is another layer that's called the granular layer. Granular because there are tons of cells that are like grains. And then in between there is one single layer, like if you do in Photoshop, that are the Purkinje cells.
Mm-hmm.
Right? And the Purkinje cells are just in the middle, are really, and a major role in the function of cerebellum, right? And they funnel all the information, and actually all the output comes from the Purkinje cells of the cerebellum. Everything goes through them and just go out. So So imagine if the Purkinje cells are gone. So
You broke the bridge.
So this is why I'm saying that in some areas the plasticity is better than in others.